Okay, so here then, this will be another tutorial for the transpose of an invertible matrix, whereas we are having here let me go ahead and everything. We'll need to step by step everything for you, don't worry. So let me, next. So the next that the transpose of the inverse of a matrix of um, of a matrix is the inverse of the transpose. So let's say we are having here a specific formula later. Let me go next. This will be the formula that we're having. The inverse of, excuse me, of A will begin to base in that formula right now that there will be a that is denoted of this one. So that follows for getting the inverse of A, that will follow with 1 over the determinant of A, and this will be this is not right, this one. Let me rectify that one. It will be that adjoint times the adjoint. So it should be like this: 1 over determinant of A, then times with the adjoint. So that's how you will deal with that. So suppose I will begin to give you 2 by 2 matrix. Then in the next video, I'll begin to also give you a 3 by 3 matrix on how you will begin to deal with that, because getting the adjoint and determinant of 2 by 2 will be different, and for 3 by 3 and for 4 by 4. And I will begin to illustrate that in different videos in the future. So let me go ahead and give you this example right now. Suppose that we will be going to base here in this particular um, example. So be mindful that in your invertible matrix class that this means that the transpose of the inverse of a matrix is really equal to the inverse of the transpose um, of that matrix. So that rule applies to invertible matrix. So let me go ahead and get so here this is determinant thing. Determinant. Right, that is determinant. So we'll begin to get right now the inverse of A, then we'll begin to transpose the result, and that must be equal to the getting the transpose of A before getting the inverse. So we'll begin to identify the inverse. Remember that this will be 1 times determinant of A, then multiply to the adjoint. So that's the formula for that. Let me rectify that to you so that everyone will not be going to be confused with our discussion. So the first thing that you need to do, you have to calculate or show the determinant. You have to show the adjoint as well. So how to deal with that? Let's actually take it slowly. Now, how to get the determinant? We'll show the determinant first. So for the determinant, the formula for the determinant is definitely, since this will be 2 by 2, it should be like this: A, B, C, D. So the determinant, the formula for determinant is absolutely A times D minus B times C. So it will become, let me illustrate, 2 times 4 minus 5 times 5. So that will be your determinant for the 2 by 2. But for 3 by 3, 4 by 4, I will begin to give to you how later on different video. So you have to calculate 8 minus 25. So you have it will be negative for this one right now. 8 minus 25, it will become negative. No, it's not 27. It's 17. Okay. That's the determinant of your 2 by 2 matrix. Now, how to get the adjoint? So the adjoint, actually, this will be the formula for adjoint for the 2 by 2 matrix alone. So remember that the 2 by 2 matrix adjoint will be like that. So adjoint, if we have to show everything, so the adjoint of our 2 by 2 will be B will be there because you will swap A and B. So this one, you will swap. So swap will become 4, and it will become 2. Then for B and C, it will be negative. So it will become -5 and -3. Why? No, no, no. It's not C. It's 5. Why it will be negative class? Because in our, if you will ask why is it negative, always be reminded that in our getting the adjoint for that one, this is actually multiplied by positive, negative, and negative, positive. That's why right now, it is absolutely 5 times negative, so that's a negative. So 5 times negative, that's negative. So that's how you will deal with that. So be reminded that this will be the adjoint right now. So we can definitely calculate this, the formula for the inverse already. So let's calculate that one. So that will become 1 over the determinant of negative 17. Sorry, negative 17. Then you will be going to times that into 4, -5, -5, and 2. What you will do, the answer for the term, I mean the inverse of A, it will become like this: 4 over 17. Then it will become -5 over -17, then -5, -17, then 2, then -17. You cannot absolutely also simplify that into fraction if you want that. I mean into decimal points, but here then you can somewhat show like that so that we will be in the same thing as well. So since that will be the A inverse right now, so what we will begin to do, since our goal is to get the transpose for that as well. So A next inverse, then transpose, the transpose for that. This first row will become the first column. So, go -5, 17. Then, that is 5, that is 17, then 2, -17. Will be like that. So, that's how you will deal with the A inverse, then getting the transpose for that out. So we are done now with the this formula. This one, A inverse, then transpose. We will now proceed with the A transpose. So we'll begin to transpose first the A. So 2, 5, it will become 2, 5, then the A transpose of things. Now is equals to 2, 5, then 5 and 4. So for this one right now, we will get the determinant, I mean the inverse. So you still have to show the determinants for that. So determinants here, it will equate the same. 2 times 4 minus 5 times 5. So 12, 8 minus 25. So it will become -17. And the adjoint will become interswap 4, then 2, then -5 and -5. So that's adjoint. Now what you will need to do, 1 over the determinant of -17 times 4, -5, -5, and 2. Okay, what you will need to do is, it will become 4, -17, then -5, to 17, then -5, -17, then 2, -17. So this will be the answer of your A transpose on the inverse, getting the inverse. Since this will be your A transpose your setup. So what we'll need to, we will be going to prove that one since it's been mentioned that the transpose of your A, transpose of your invertible A will be equal to the transpose of A, then getting the inverse of her. So let's try to identify. So 4 and negative 17 and negative 5, negative 17, correct? Negative 5, negative, oh, correct? And correct. So they are equal and they are the transpose of invertible matrix. So I'll begin to illustrate in the another video, the 3 by 3, so that you will be in the same page as well in the examination. Thank you.